Welcome back to the deep dive. Today we're diving into something pretty cool. Smoke.
Smoke?
Yeah, have you heard of this?
Yeah.
So it's this mobile messenger, and it's using some seriously impressive cryptography to keep your messages private.
Right.
We're going to really try to understand how Smoke is using the McEliece algorithm and its variations.
Okay.
And, this is a pretty hot topic in cryptography right now, especially with quantum computing coming up.
Yeah, it's a really interesting time for cryptography, and certainly McEliece is getting a lot of attention.
For sure.
And it's because a lot of commonly used encryption methods like RSA could be cracked wide open by a powerful enough quantum computer if and when those ever become a reality.
Yeah.
But McEliece is considered quantum resistant, and Smoke is one of the first real-world examples of that algorithm.
In action.
I
love that.
Yeah.
So they're not just saying it's private, they're actually using cutting edge.
Yeah, they're walking the walk. Yeah. It's not just marketing.
Okay, so remind me, how does McEliece work again?
So McEliece uses this clever idea of disguising a message to look like random noise.
Okay.
By using something called error-correcting codes. And only someone with the secret key can actually decode that message.
Okay, so
it's kind of like sending a secret message written in invisible ink.
Okay.
It just looks like gibberish unless you know how to reveal the message.
Hiding in plain sight.
Exactly.
Like it.
Yeah.
But you mentioned variations.
Yes.
What are those all about?
So the McEliece algorithm has actually been around since 1978.
Wow.
And in that time, researchers have been coming up with different ways to make it even stronger and more efficient.
Okay.
These variations are often referred to as modulus implementations.
Okay.
And Smoke uses a really powerful one.
So modulus 1, 2, 3, 4.
Yeah.
It's like levels in a video game.
Yeah, you can think about it like that.
Higher modulus equals higher security.
Generally speaking, yes. Higher modulus versions do tend to offer more security.
Okay, I'm ready to level up. Let's start with modulus 1, the OG McEliece.
All right, so modulus 1 is often called classic McEliece.
Okay.
It was developed by Robert McEliece himself.
Back to basics.
Back to the basics. And this is kind of the foundation for everything that came after.
And you mentioned these parameters a minute ago. What did those actually mean in practice?
Yeah, so in classic McEliece, the parameters are represented as m equals 11 and t equals 50.
Okay.
You can kind of think of them as like the strength settings for your message encryption.
Gotcha.
M relates to the length of the code used to encrypt your message, while t relates to the code's ability to correct errors.
So the higher the M and T, the tougher it is to crack the code, even if there's...
That's exactly right.
...interference.
Yeah, like noise or anything like that.
Okay, cool.
Now let's fast forward a bit.
Okay.
Modulus 2 brings us to Japan.
Ooh, international collaboration. I like it.
Yeah, so researchers, Eiichiro Fujisaki and Tatsuaki Okamoto, they were busy making McEliece even better.
Okay, what did they change?
They focused on tweaking the algorithm for both increased security and efficiency.
Okay.
Their version Modulus 2 uses slightly higher parameters, m equals 12 and t equals 68.
So they cranked up the security settings just a little bit, but it still works smoothly.
Yeah, it did.
That's impressive. Where does the story go from there?
Next, we hop over to France.
Ooh la la.
David Pointcheval, a French cryptographer, dove deep into strengthening McEliece against specific types of attacks.
Okay, did he up the M and the T even further?
This is where it gets interesting.
Okay.
Modulus 3 actually uses the same M and T values as Modulus 1.
Oh, wow.
M equals 11 and T equals 50.
Interesting.
But remember, it's not just about the numbers themselves. Yeah. It's about how the algorithm is implemented. Pointcheval made significant changes under the hood that dramatically improved security, even though those specific parameters stayed the same.
Wow. So it's like he optimized the code without having to make it longer or more complex.
Yeah, you got it.
That's pretty clever.
Yeah, he found a more elegant solution within the existing framework.
I'm starting to see why you're so fascinated by this.
Yeah, it's pretty cool.
Okay, I'm ready for the grand finale. Bring on Modulus 4.
This is where things get supercharged.
Okay.
Modulus 4, also known as Super-McEliece, is the brainchild of Text Browser, the developer of Smoke.
Oh.
They knew that they needed the strongest possible protection for user messages.
Right.
So they went all out.
All right. Hit me with those supersized parameters.
M equals 13.
Okay.
And T equals 118.
Whoa.
Yeah. They significantly boosted the values.
Yeah.
Aiming to create an encryption scheme so strong that even future advancements in code-breaking techniques would have a hard time cracking it.
So when I'm using Smoke, my messages are being protected by this Super-McEliece Modulus 4.
You got it.
Okay, cool.
Well, they took all the best advancements from previous Modulus versions and they pushed them even further to create a truly cutting-edge implementation of McEliece.
It's like a global effort with researchers all over the world, kind of.
Yeah. It's really cool how it's built on...
Building on each other's work.
Building on each other's work, exactly.
To create something truly remarkable.
Yeah.
But I do have one concern.
Okay.
Wouldn't using such high parameters make the encryption process really slow?
You're absolutely right.
Especially on a mobile device.
Normally, yes, higher parameters do mean that you need more processing power.
Yeah.
But the Smoke developers, they were really clever about it.
Okay.
They put a lot of effort into optimizing their implementation specifically for mobile devices.
Okay.
And the result is you get all that security without sacrificing speed or performance on your phone.
That's fantastic.
Yeah.
So I can be confident that my messages are being protected by some of the most advanced cryptography available?
Absolutely.
Without my phone slowing to a crawl?
Without your phone slowing to a crawl, exactly.
Oh, amazing. Yeah. What's the reaction been like in the cryptography community?
Smoke has definitely caused a buzz.
Yeah.
I mean, using a quantum-resistant algorithm like McEliece is impressive in itself.
Yeah.
But then when you add the Super-McEliece adaptation,
right,
it's really pushing the boundaries of what people thought was possible with this algorithm. And a lot of folks are taking notice.
I can imagine. It's like Smoke is showing the world what the future of secure messaging can look like.
That's a great way to put it.
Yeah.
And speaking of the future, what's particularly fascinating about Smoke is that it begs the question, what does the future hold for secure messaging?
Ooh.
Is there something even beyond McEliece on the horizon?
Okay, wow, that's a big question. So we talked about how Smoke is using McEliece to make messages super secure.
Right.
Especially with their Super-McEliece setup.
Right.
But you're saying there might be even more advanced stuff out there.
It's possible.
Okay.
I mean, it's a rapidly evolving field.
Yeah.
And the emergence of quantum computing really throws a wrench in the works.
Right, for sure.
That's why researchers are already looking at what comes next, trying to stay one step ahead.
Makes sense. So what are some of the things that they're exploring? What could be even more secure than McEliece?
One of the most promising areas is something called lattice-based cryptography.
Okay.
It's kind of like McEliece
in
that it's considered quantum resistant, but it relies on completely different mathematical concepts.
Lattice-based. That sounds kind of geometric.
It is. It uses complex geometric structures called lattices to create problems that are really hard to solve.
Okay.
Even for quantum computers. Think of it like this. You have this multi-dimensional maze, and the only way to navigate it is with a specific key. Okay. Without it, you're just going to keep running into walls.
So using math to create basically unbreakable codes.
That's the idea.
Okay, cool.
And what's really cool about lattice-based cryptography is that it's incredibly versatile.
Oh, okay. How so?
It can be used for things like encrypting messages, creating digital signatures. Okay. And even for super advanced stuff like fully homomorphic encryption.
Whoa, hold on.
Yeah.
Fully homomorphic encryption. That sounds like something straight out of a science fiction movie.
I know, right?
Okay, what is that?
It's mind-blowing. Imagine being able to perform computations on encrypted data without ever having to decrypt it.
Wait, so you could analyze sensitive information without actually seeing the information itself?
That's exactly right.
That's pretty crazy.
Yeah.
That'd be huge for like healthcare and finance, all these
It's huge for healthcare finance.
Cloud computing.
Cloud computing.
Where data privacy is super important.
You could process data in the cloud without worrying about anyone snooping on the sensitive information.
That's incredible.
Yeah.
Are there any messengers out there that are already using this lattice-based cryptography?
Not that I'm aware of.
Okay.
At least not in widespread use. SMIRC is definitely pushing the boundaries with its use of McEliece.
Yeah.
But lattice-based cryptography is still mostly in the research and development phase.
Gotcha.
It's going to be exciting to see how it develops in the coming years, though.
For sure. I'm definitely going to be keeping an eye on that.
Yeah.
Okay, so we've got these incredibly powerful algorithms like McEliece and lattice-based cryptography.
Yeah.
But even if we have these like unbreakable codes, are there other things to consider when it comes to secure messaging?
You're hitting on a really crucial point.
Right.
A crypto system can be mathematically brilliant.
Right.
But if it's too difficult to use, no one is going to adopt it.
Yeah, it's got to be easy.
Right. You need to find that sweet spot between strong security and user friendliness.
Yeah, for sure. Like, I'm all for my messages being protected by all this crazy math.
Right.
But if it takes me like an hour to send a simple text, I'm probably going to give up and just use regular old iMessage or something.
Exactly. And that's a challenge that developers like text browser are really grappling with.
Yeah.
They want Smoke to be as secure as possible, but they also want it to be something that everyone can easily use.
It's like they're trying to make Fort Knox level security
Yeah.
as easy to use as like sending a text message.
That's a great analogy.
Yeah.
And that's why I think Smoke is so interesting.
Yeah.
It gives us a glimpse into a future where security and privacy are just built into the way we communicate.
I love that.
Without sacrificing usability.
Yeah.
It's about making secure messaging the default, not just an option for tech-savvy users.
So it's not about building these like fortresses of encryption that are impossible to use.
Right.
It's about making privacy and security accessible for everyone.
Precisely.
I like that a lot.
And as awareness of these issues grows, I think we're going to see even more innovation in this space.
Yeah, for sure.
Smoke is just the beginning, and I'm really excited to see what comes next.
This has been an incredible deep dive so far. We've gone from understanding how Smoke uses McEliece to exploring these possibilities of lattice-based cryptography and the future of secure messaging.
It's been a lot of fun.
Yeah, it has been a lot of fun.
It's always a joy to talk about these topics with someone who's so genuinely interested.
Speaking of being interested, something you said earlier really got me thinking. You were talking about how even with these unbreakable algorithms, the human element can still be a weak point.
Oh, absolutely.
That really got me thinking.
Yeah.
Like, even if we have Fort Knox level security on our messages,
Right.
someone could just leave the keys lying around.
Exactly. You can have the most sophisticated cryptography in the world, but if someone falls for a phishing scam
Right.
or reuses the same weak password across different accounts, it can all be for nothing.
So it's like security is only as strong as the weakest link.
Yeah.
And a lot of times that weakest link is us, the users.
Unfortunately, that's often the case.
Yeah.
And the techniques that attackers use are constantly evolving, too.
Oh, yeah, for sure.
Social engineering, where they manipulate people into giving up sensitive information, is becoming more and more sophisticated.
Wow.
It's scary how convincing some of these scams can be these days.
Yeah, I've seen some phishing emails that look so real,
Oh, yeah.
especially if you're not expecting it.
It's easy to fall for them.
Yeah.
And, as technology gets more advanced,
Yeah.
we can expect these types of attacks to become even more convincing and harder to detect.
So even with quantum-resistant algorithms like McEliece,
Right.
we can't just assume that we're totally safe.
Exactly. It's not a silver bullet.
Okay, so what can we do about it? Is it just a matter of being more careful and aware?
That's a big part of it, absolutely.
Okay.
Being aware of the different types of social engineering tactics,
Mm-hmm.
using strong and unique passwords,
Right.
and being cautious about what information you share online are all really crucial steps.
It sounds like education is a big part of it, too.
Absolutely.
The more people understand about these risks, the less likely they are to fall victim.
You got it.
Okay.
It's about creating a culture of security awareness.
Yeah.
And it's not just about individuals either.
Yeah.
Companies and organizations have a huge role to play in implementing strong security practices and training their employees to be vigilant.
It's really a team effort then.
Yeah,
Technology can only take us so far. The rest is up to us.
that's a great way to put it.
Okay.
And I think it highlights something really important about security.
What's that?
It's not a destination.
Uh-huh.
It's a journey.
Okay.
It's an ongoing process of learning, adapting, and staying one step ahead of the bad guys.
So even with all the amazing advancements in cryptography like Smoke, using McEliece,
Right.
there's no guarantee of absolute 100% security.
Unfortunately, there's no such thing as 100% security in any system.
Okay.
The goal is to make it as difficult as possible for attackers to succeed,
Right.
but also be prepared to respond and adapt if they do find a way in.
That makes a lot of sense.
Yeah.
It's like a constant arms race
It is.
with both sides trying to outsmart each other.
Precisely.
Wow.
And that's why it's so important to have these open and ongoing conversations about these issues.
Yeah, for sure.
The more we understand about the complexities of security and privacy in the digital age, the better equipped we'll be to protect ourselves and our information.
Well, this deep dive has really opened my eyes to the incredible world of cryptography and the challenges we face in securing our communications.
It's fascinating stuff.
I feel like I've learned so much from the technical details of McEliece to these human factors that play such a crucial role.
Yeah, it's a multifaceted issue for sure.
It really is.
It's been a pleasure sharing this journey with you.
Likewise.
I hope it's sparked a sense of curiosity and awareness in you and in all of our listeners.
Absolutely. Thanks for taking us on this fascinating deep dive.
My pleasure.
And for everyone listening, don't forget to check out the show notes for links to all the research papers and more information about smoke.
Yes, definitely check those out.
Until next time, stay curious, stay safe, and stay secure.